How do you know you're real? What if you're living in the Matrix? Is the bite of food you put in your mouth real? What if a simulation is merely telling your brain that the bite tastes juicy and delicious, when in reality you're not eating anything at all? This idea is not just limited to the plot of the Matrix movies. Known as the simulation theory, and frequently brought up not only by everyday people, but also by hugely popular figures like Elon Musk and Neil deGrasse Tyson, it continues to be debated in a wide variety of contexts within philosophical and scientific circles. Indeed, recently, the famous computer scientist Roman Jampolsky claimed in a program he attended that artificial intelligence could be the tool to free us from this simulation. Yet, even though simulation theory is this popular, no one really gives a neat, straightforward explanation of what the core argument of this theory is or why we might take this possibility seriously. So today, we're going to learn those reasons together. Gather around. What is the simulation argument? What does it claim? And why are we almost certainly not living in a simulation? Let me tell you. Cosmologists use massive supercomputers to produce highly detailed simulations in order to better understand the universe and shed light on our physical past. In the last few years, we've made such significant progress in this area that it's now nearly impossible to distinguish some cosmic simulations from real images. You can get a taste of a much simpler but still impressive version of this yourself by playing with simulators like Universe Sandbox. Depending on the depth of the simulation, experts can generate stars, star systems, and even planets on a computer. In fact, depending on the level of detail in which those planets are simulated, it may even be possible to provide the initial conditions for life and simulate single-celled organisms. The rest would just be a straightforward evolution simulation. In other words, we have already begun transferring what happens in the real universe into computers. And this is only the beginning. Think about it. Just 40 years ago, we were playing Tetris. Now we're immersed in hyper-realistic computer games. Have you seen the scenes created with Unreal Engine 5? Have you tried games still in beta like Bodycam or Unrecord? The footage you're seeing right now is not video. It's where game simulation technology has reached. Imagine what kinds of games we'll be playing 40 years from now, especially once VR undergoes its own revolutionary leaps. And what about 4,000 years from now? Will we be able to tell them apart from the real world? In a future game, if we get punched, will our muscles contract uncontrollably? Will blood come out of our nose? Because never mind the goggles. Increasingly advanced brain-computer interfaces will allow us to connect electronic circuits directly to our brains, creating unreal images, sounds, and sensations in our minds, enabling hyper-realistic simulations and games to send real signals through our bodies via our brains. When we train our rapidly advancing AI within these hyper-realistic simulations, perhaps some of them might evolve conscious minds that feel as though they are living in a real world. In the literature, we call a future like this the post-human phase, which gives its name to transhumanism. In short, during this phase, humanity would be capable of creating universe simulations so realistic that any consciousness inhabiting them wouldn't be able to distinguish them from true reality. And that's exactly why simulation theory pushes us to question our own reality. How can we be sure that the intensely realistic experience we have is truly, physically, absolute reality? In other words, what if we are in a simulation created by a civilization that has already reached its post-human phase? But that's a very strange claim, isn't it? Because, for instance, I know I've been around for about 30 years. I even have photos of my birth. So do my parents. All my friends confirm their own existences. So how and at what point could the simulation have started? Frankly, it could have started just last Thursday. Think about it. Yes, we're aware not only of our own past, but also of the millions of books written over millennia, of the hundreds of thousands of fossils spanning billions of years, and of all manner of geological records. But all of that could have been simulated last Thursday, presented to our consciousness as though it were ancient. Also, our memories could be consistently created by the simulation, making it appear that everyone remembers very old events. Known as last Thursdayism, this view can be a perfectly plausible possibility if the universe is indeed a simulation. Granted, you might try to sidestep the issue by saying, "I think, therefore I am." But nobody's claiming you don't exist. The consciousness within simulations is just as real as the consciousness in a physical universe. At least that's not the main debate. It's simply that one is made up of real quarks and atoms, while the other is composed of computer code that simulates those quarks and atoms. So how do we know our quarks are the real ones? In other words, how can we tell if the universe is a simulation or not? Unfortunately, there's no easy way. Because a civilization capable of creating a simulation indistinguishable from reality would probably write sufficiently advanced code to fool consciousnesses within that simulation. Still, no software is perfect. Therefore, looking for inconsistencies with the fundamental rules of our universe, glitches, as they're called in the Matrix films, could be one experimental way to probe this. Such glitches could stem from the fact that simulated universes would need to be modeled with discrete pixels. This kind of modeling, conflicting with the continuous physics we believe to exist, could create observable anomalies. But the problem is that any discovery we might classify as an error in a simulation can typically be explained by other, more ordinary explanations. Proving that they can't be so explained remains a challenge. Hence, rather than presenting direct evidence of simulation theory, or more accurately, the simulation hypothesis or simulation argument, tries to demonstrate how likely it is that we're living in a simulation, offering what it considers a rational line of reasoning. And this argument rests on 4 key assumptions. First, everything in the universe, ranging from human consciousness to quantum mechanics, from stellar astrophysics to nuclear chemistry, from psychiatry to microbiology, must at some level be mathematically modelable on a computer. Because if there's anything in the universe with a nature that can't be simulated, then we can't speak of simulation theory at all. But from what we've seen so far, it appears that, one way or another, all known qualities of the universe can be transferred to a computer. If not now, then perhaps very soon. Second, the position of humans or any other consciousness in the universe must not be special. That is, conscious minds like ours should be able to arise naturally, without any supernatural intervention. If for some reason consciousness were not entirely physical, then we couldn't talk about simulation theory again, because no matter how hard that truly physical civilization tries, they wouldn't be able to create a consciousness on a computer. But all of the evidence we currently have strongly suggests that consciousness is likely entirely physical, so that seems to check out as well. Third, technology produced by conscious beings must not be innately prone to destroying its creators. After all, if the conscious beings that develop advanced technologies are ultimately destroyed by those same technologies, then the first actual civilization that created a simulation would itself be destroyed by its technology, and thus might never kick off a simulation theory scenario. In other words, if naturally evolved conscious beings can't effectively control their technology, eventually wiping themselves out via atomic bombs, artificial intelligence, nanorobotics, bioengineering, etc., then we can't talk about simulation theory. In that sense, biological intelligences must be not only smart, but also smart enough not to self-destruct. Personally, I'm not so sure about that part, but let's assume it's valid just so we can move on to the core argument. Fourth and finally, conscious beings should feel strong curiosity about their own history and existence. If a civilization doesn't care about understanding its past or its current state, it likely won't be motivated to create simulations of itself or of other similar conscious entities. Alternatively, maybe they do care about their past, but find the idea of creating a hyper-realistic simulation of themselves unethical. Because there's so much suffering, death, evil, and disease in our world. Perhaps they don't want the responsibility of being the creators of beings who would experience such hardship. But seeing the inherent curiosity in ourselves and all other animals, we can reasonably guess that many conscious beings would have such a drive, and that at some point that curiosity might outweigh ethical concerns. So if these 4 premises are somehow correct, then a truly fascinating scenario emerges. As suggested by the Fermi paradox, given the immeasurable spatial and temporal vastness of the universe, consciousness likely emerged at some point, evolved, became more complex, and built civilizations. At some point, it's natural that they would want to simulate their own past. Just as we make simulations to study evolutionary biology or develop them to clarify cosmic history, these post-human superintelligent beings would eventually create simulations. And within those simulations, they would give rise to new consciousnesses. Those consciousnesses, just like themselves, would evolve, grow more complex, and build civilizations. Remember, it's their simulation. And inevitably, the simulated consciousnesses would also become curious about their own existence and attempt to build their own simulations. The consciousnesses that arose in those simulations would do the same, and so on. In other words, whether inside a simulation or not, once a consciousness reaches a sufficiently advanced level of technology, it would likely build hyper-realistic simulations to better understand its own past and existence. If our four initial assumptions are correct, these simulations would stack like matryoshka dolls, nested layer upon layer. Every simulation's consciousness would create its own simulation. And if there were enough time, this could continue for thousands, millions, maybe even trillions of layers. So then I ask you, in a chain of simulations that has trillions of layers, if you were to be born at some random layer, what are the chances you'd be in the very first real layer that created the original simulation? Practically zero. If you randomly point to any layer in this enormous chain, that layer is almost guaranteed to be a simulation created by earlier ones. Therefore, you are almost certainly in one of those layers right now, not in that topmost original real layer that started it all. Chilling, isn't it? The person who first put forth this argument, Oxford University philosopher Nick Bostrom, in his 2003 paper titled, "Are You Living in a Computer Simulation?" doesn't actually claim outright that we definitely live in a simulation. Rather, he notes that if we aren't living in a simulation, then at least one of the assumptions we've discussed must be wrong. And whichever assumption turns out to be wrong would yield incredibly interesting insights about ourselves and our civilization. Think about it. If we're not in a simulation, our technology might be inherently programmed to destroy us at some point. Or perhaps biological evolution is incapable of producing species intelligent enough to avoid self-destruction. Or maybe consciousness is something specially created in the universe. Or simply civilizations don't care about their own existence, the nature of the universe, or their past. Each of these is a groundbreaking possibility. But if all the assumptions hold true, we'd have no choice but to conclude that we do indeed live in a simulation. Both of these options are truly mind-boggling. And in fact, simulation theory isn't just a cool possibility. It also offers explanations for some intriguing observations about the nature of reality. For example, in earlier videos we talked about the measurement problem in quantum mechanics, how the probability distribution of a quantum system seems to collapse to a single outcome the moment it's measured. This phenomenon can be somewhat accounted for by the simulation argument. If we are inside a simulation, maybe not everything in the universe needs to be rendered at every moment. Otherwise, the hypercomputer's processing power would be wasted. For instance, if you leave your phone in the living room while you go to the bathroom, the simulation might not continue modeling that phone or even the living room after you leave. Its simulation might end the moment you walk away until you observe it again. In other words, simply rendering wherever a consciousness is focused, or where an actual measurement is made, is enough to provide a convincing experience. Even modern VR headsets employ a related principle of selectively rendering only what's in the user's field of view, rather than everything all at once. Likewise, simulation theory can also explain anomalies such as déjà vu, the so-called Mandela effect, like people remembering Pikachu's tail having a stripe or believing Nelson Mandela died in the 1980s, and similar phenomena by suggesting they are glitches, the very sort of concept made famous in The Matrix. Neat, right? But despite all this, there's still a very high likelihood that you're not living in a simulation. First, the measurement problem and phenomena like déjà vu, which I said could be solved by the simulation argument, already have simpler, more plausible explanations. But more importantly, the assumptions upon which the simulation argument rests are not so easy to swallow. First of all, the idea that the entire universe can be uploaded into a computer is a massive assumption. Even though we haven't yet found anything that appears to be impossible to simulate, aspects of the quantum world, like superposition and entanglement, human consciousness, the absurd scale of the universe, or, if it exists, free will, might turn out to be impossible to simulate. We just don't know. Similarly, with our current understanding, we don't even know whether the fabric of space-time is quantized or continuous. If space-time isn't quantized, but is in fact continuous, then modeling it authentically on a computer might be exceedingly difficult, since computers typically rely on discrete elements like pixels, iterations, or time steps to simulate anything. Moreover, Gödel's incompleteness theorems, which I'll describe in upcoming videos, show that there are certain truths within formal systems that can't be verified by the system itself. This implies there may be logical barriers in a physical universe that can't be simulated or predicted. And as we recently discussed, deterministic chaos, the subject of chaos theory, may also pose significant challenges to our simulations. But these are not the reasons that convince me we're not living in a simulation. I think there are three far more critical points. The first one basically relies on the law of entropy. The computers running these simulations would require an absurd amount of energy, so much that some experts doubt our own universe even contains enough energy to power such a simulation. Even if it does, the resolution of the simulation we create would have to suffer certain losses due to the law of entropy. Hence, any simulation we create must be lower resolution than the universe itself, which we might currently be inside. Because resolution is ultimately determined by available physical energy resources. As resources become more constrained, resolution drops. Lower resolution, in turn, would produce more and more noticeable distortions in each layer of simulation, and these distortions would grow exponentially. Because if there are 1,000 layers of nested simulations, the topmost layer must not only power its own simulation, but also all the simulations within it. That's an unfathomable amount of energy, and each simulation layer would degrade the resolution a bit more. But here in our universe, we're not seeing any conspicuous drop in resolution of that sort. So either we're incredibly lucky to be in one of the topmost simulation layers, or we're not in a simulation at all. But I think the second reason is more crucial. Simulation theory posits that each simulation layer would go on to create its own hyper-realistic simulations. The problem is that we don't yet have hyper-realistic simulations inhabited by conscious beings. Right? If you think about it, that's a huge problem for the simulation theory. It would imply that we are the very last layer among the trillions of layers. Statistically, that's as unlikely as being in the first layer. And since the assumption that our universe is the genuine article requires fewer additional assumptions than the idea that it's a simulation, Occam's razor encourages us to reject the more convoluted hypothesis. Therefore, I believe we are not currently in a simulation. We're in the real universe. And the third and possibly the most significant reason is the burden of proof. It rests on those who claim we're living in a simulation. People like Elon Musk, who advocate for the simulation argument, have not provided empirical evidence that meets scientific standards. It's also very unclear how one could ever verify such an argument. It appears to be nearly unfalsifiable, which renders it unscientific. Consequently, the concept of the null hypothesis in science nudges us toward accepting that the claim is false. In other words, when faced with an unproven positive claim, we assume its negation is correct, and then try to disprove that new assumption. Let's not kid ourselves. If we manage to disprove our null hypothesis, i.e., the assumption that we're not living in a simulation, then great, we'll have proven we are in one. But if we can't, then we avoid blindly accepting a claim with no supporting evidence. This methodology is why science is so powerful. That's it. For all these reasons, I think we're currently not living in a simulation, but I'm completely open to your ideas. Feel free to share them in the comments. On the bright side, maybe that crazy possibility is real, and we're the first civilization with the potential to create entire universes. What would a universe look like if you could set all the rules? Be sure to share in the comments. For example, in a world we simulated, initiatives that contribute to the public's intellectual development and strive to enlighten society would lack basic material needs. If some people worked day and night to bring modern science to the public, they would be guaranteed basic resources such as food, shelter, and rest. But we're clearly not living in that kind of simulation. See you in the next video. Goodbye for now.